All right. Good morning, folks tuning in both on News 6, the YouTube channel, as well as our News 6 Plus app. As you all are very familiar with, I'm News 6 meteorologist David Nazario, and as we are all well aware of, we're talking and we've been thinking, digesting, interpolating, forecasting, everything you want to put on the table this bitter cold weather. And it is finally here. But today we're not going to be dabbling in that too much. I feel like we've beaten the dead horse quite a bit. We know it's cold. It's going to stay cold. And of course, if you join us later on for our Take 6 show, I'll have the latest on your national and local forecast during our 12:30 Take 6 event. But today we're actually joining you to talk about something pretty unique and specific to Central Florida, or is it as unique as we may believe? We're taking an in-depth look at a brand new lightning report, and it's a fascinating topic that we just got our hands on. Some really interesting trends from 2024. The research was released just this morning by Vaisala X Weather, and we're going to talk about who earned the spot as the lightning capital. And we all, especially if you're native to Florida, we're all very familiar with lightning, thunder and lightning. We were supposedly the lightning capital of the United States and potentially the world, was the rumor in circulation around our viewing area. We're also going to discuss a little bit of the impacts that it has on Central Florida, to which both of us here, as well as my guest, can testify how it affects air travel. My prior United States military service, we had a lot to do with forecasting for our personnel out on the flight line and the lightning impacts that we could potentially face. So, with that being said, we're going to go ahead and kick things off right away. Today, we are joined by Ryan Said, Senior Lightning Scientist at Vaisala X Weather. Ryan, thanks so much for joining us. And let's start off with a little bit of your background, sir, if you want to go ahead and take the mic for a little bit.
Thanks very much for having me this morning. Really happy to be here. As you introduced, I work for Vaisala. I'm a research scientist and an engineer. I work on all aspects of our lightning detection technology. So we are a Finnish-based company with a large presence in the US, and we
Okay.
offer a wide variety of products for meteorological and environmental monitoring, and real-time lightning detection is one of those.
That's awesome, honestly. And I'm so glad that you said Vaisala, because those are the two different ways I've always heard it pronounced. When I was serving active duty in the Air Force, we had our FMQ 19s and the TMQ 53s for weather sensing, both in the field and then just at your local airbase. And we had a lot of the Vaisala equipment on there for the lightning detection specifically. So it's kind of cool finally getting to speak to somebody who works with the inner machinations of all that, which I think is fantastic. What started it all out for you? Did you happen to just get started with Vaisala, or was there always like a bit of a build up to joining that name, that industry?
Vaisala has been in the lightning detection business for 25 years. I personally came to the company around 12 years ago. As a PhD student, I started developing technology that would eventually morph into our global lightning detection network. So that's
Okay.
personally how I came to be at the company.
Got it. So you were the one to help kind of pioneer stepping into that global perspective as opposed to just keeping it localized to the United States. Am I understanding correct?
That's correct, yes. The Vaisala has operated the National Lightning Detection Network in the US for over 40 years.
Oh, wow. So it's been out there for a long time. See, truthfully, I've worked with some of the equipment on a very localized scale, but I did not know how much of a footprint that they've had, especially with lightning. And for those of us who aren't savvy with lightning detection, could you give us, just like a general overview? And it doesn't have to be weather-esque or weather nerd at all. I understand you're not a meteorologist, so I'm not going to put you on the spot in that department, but just how does it work in the simplest of ways? Is it satellite detection? Are there sensors in the ground and in the air, or is it like a three-dimensional kind of thing?
Yeah, certainly. So it operates with a network of radio receivers.
Oh, okay.
Lightning itself is a powerful electrical discharge. It's the most powerful natural process on Earth. And each lightning flash generates a powerful radio burst that blasts out in all directions.
Wow,
And
okay.
what we do is we operate a network of sensors all around the country and the world that listen for these radio bursts from individual lightning flashes. And we measure with GPS timing the precise time and the direction at which these radio bursts arrive at the sensors. And then we can use those measurements to pinpoint the lightning location itself.
That's really cool. I understand the discharge and the electrical power behind a lightning bolt, as Dr. Emmett Brown said, 1.21
Mhm.
gigawatts for our Back to the Future fans out there. But I had no idea that it dabbled with radio sensory material. And is it safe to kind of assume for folks who may not understand how radio waves work, it's very similar to, say, for instance, when an earthquake hits and the seismograph finally receives the tremors and begins to pick it up? Is it similar to that when the lightning hits and the sensor finally picks up on that information?
That's a really great analogy. Both involve waves that travel at a certain speed. So in the seismograph, you'll have waves in the ground that have, some acoustic-like speed, whereas radio waves travel at the speed of light. You can think of lightning as kind of like a big broadcast antenna that's temporarily out in the sky and is blasting these radio pulses that we can then detect at multiple stations. And just like with seismographs, you can pinpoint the epicenter. The process of locating lightning from radio waves from lightning is very similar. The math is very similar to what you do for a seismograph.
That's great. That's excellent information, truthfully, because now, especially when we're watching severe weather here in Central Florida real time, we can better explain to our audience exactly how we're picking up on the lightning strikes, the differences between cloud to ground, in cloud, which kind of leads me into another small question for my own curiosity. If it doesn't hit the ground, is it just the bolt itself and the energy that it produces that the radio sensors will then pick up on, or does it need to come in contact with the ground itself?
We detect both cloud to ground strokes and what we call cloud pulses that don't actually make contact with the ground. Each of these types of lightning acts as basically a radio wave generator, like a large antenna. It's just the difference is the channel lengths are a bit shorter if it's just in the cloud. But the physics behind the electrical currents and the radio waves that they generate are quite similar between those that hit the ground and those that are just in the cloud. So we detect both.
Wow, okay. Again, excellent information. I hope those of you tuning in over on News 6 on the YouTube channel, if you do have any questions, by the way, since we are live, if anyone does want to drop a question in the chat, feel free to do so, and I can relay that over to Ryan. I'm sure he'd have no problem taking a quick second to address any questions you may have, or after the fact, if you do have something in the comments section, feel free to drop it below. Ryan, would you be opposed if we do have any questions from viewers, if maybe we reach out to you after the fact, with a little how goes it, hey, just touching base, so-and-so asked this, and we thought it'd be kind of cool to run it past you?
Not at all. This stuff is really cool in my opinion, so always happy to talk about it with folks.
Beautiful. I love it. So, with that being said, before we run into our first break, this is one of the graphics that was provided to us showing the lightning data for 2024. And for those of you who have been following News 6 or any weather social media, digital platform, or broadcast, as we all know, 2023 into 24, we were under that El Nino winter. And you can kind of pick up pretty much where most of the severe weather and thunderstorm activity occurred in eastern Texas, the Dixie Alley, the Deep South area, and Central Florida. Ryan, if you could talk to this graphic for maybe just a minute or two, kind of break down some of the statistics that we're seeing amidst all the psychedelic colors.
Yeah, what you're looking at is something called a total lightning event density. This is how many lightning events did we detect with our National Lightning Detection Network per square kilometer or per unit area. So it's sort of a measure of the intensity or the amount of lightning that you see in each region. And the color scale reflects the total density value. It goes from less than 1 in those blues and light greens to over 250 or so for those dark reds.
Wow, okay.
And the units are per square kilometer, so you multiply that by 2.56 to get per square mile.
Copy that. Okay. So the colors here aren't necessarily how many lightning bolts we saw in that specific spot. It's going to be, I would assume, within that grid reference that you mentioned with the numerical values, how much, as the name implies, the density, just how much lightning typically occurred within that geographic point. Is that correct?
That's correct, yes.
And I do see here in the statistical data to my right that Texas is now officially beating Florida in terms of the lightning capital. Is it safe to say that Texas is the new capital for the US?
There's a few things I want to tease out here.
Okay.
The first is, let's just talk about total counts over an area.
All right.
So we rank the different states based on how much lightning did they see. And obviously, this is an interaction between sort of the intensity of lightning and how big the state is. So Texas always wins just on pure counts because there's a lot of lightning there and it's a really big state.
That makes sense.
But if you look at the density over the entire state, Florida always wins because density is normalized by area. And so, on a per region basis, lightning is just more frequent and more intense in Florida on average than it is over all of Texas. Then instead of a whole state, we can zoom into individual counties or just look at these pixel densities from this map and identify a location that saw kind of the most intense amount of lightning or the most localized amount of lightning over a small town region. And with that metric, there's a town in Texas, Teague, Texas, that took the prize this year. They saw a lightning density of over 1,900 events per square mile.
Wow. That's impressive. Okay. And I also notice here, as a matter of fact, which, by the way, folks, if you are still watching, that does mean that Florida still keeps the crown in terms of lightning capital, especially considering you could probably fit at least two, if not three Floridas into Texas. So they have that handicap, that little advantage over us when it comes to the surface area. But I am noticing here that for Central Florida, which stands out to me because I reside in this area, Polk County was named as the top lightning spot. What was that all about? Was there any kind of specific phenomena that you guys observed in that county specifically? Because we do get a lot of lightning. I remember last summer especially, there were countless times before coming on over to News 6 where I had to call up my supervision as a remote employee and say, yeah, lightning hit. We're without power again. It would happen on like a day-to-day, if not at least a week-to-week basis.
That's right. Yeah, it's really just a reflection of how common occurrence lightning is in Florida. You have all the main ingredients for thunderstorm formation, which of course is the precursor for a lightning flash. You've got the moisture and the diurnal heating, so you've got warm, moist air that can rise, and so all those ingredients that you need for thunderstorms is just readily available year round in Florida, and so this is why we routinely see it as the highest lightning density in the U.S. And accounts over a county being the highest in the country isn't surprising either.
Wow, okay. So that makes me feel good. It's kind of like a bittersweet feeling that Polk County, because I'm out of Haines City in Central Florida, and that's like the upper northeast quadrant of Polk County. We get a lot of lightning out in that general area, especially during the sea breeze during the summertime, where the storms are pressing in from Tampa across the peninsula and they hit that convergence area, and then it's just off to the races from there. The atmosphere just unzips for all intents and purposes. So, all right, folks, we do have a couple more questions that we'll get to here in a moment. I don't see anyone in the chat just yet. We're going to take a quick 2-minute break and come right back to you, and then we'll kind of wrap up with a couple more how goes it questions and maybe touch on some of the local weather that we're seeing here in Central Florida if time permits. So don't go anywhere, folks. We will be right back. And then, Ryan, since we're looking at a live shot right now, I probably should have said this before I tossed us to break, since our YouTube viewers can definitely hear me right now as we admire this beautiful live shot. But we'll stand by for just about another minute 25, and then we'll pop right back up and get ready to wrap things up, all right? And welcome back, everybody. If you stuck with us over on YouTube, you probably heard that little narrative going on in the background. That's definitely my bad. First interview on the News 6 channel here out of the Digital Weather Center. So, naturally some growing pains, but I'd imagine we're doing fairly well for ourselves. And now, Ryan, do you happen to have a little bit of expertise in how a lightning strike is formed? Because there's a little fun fact I wanted to shout out to the viewers here in just a second. Once we kind of open up that can of worms just a little bit, how a lightning strike comes to be.
Sure, happy to talk about it.
Yeah, so go ahead and if you wouldn't mind just breaking down the simplest way to see a lightning bolt kind of get cranking out there in the middle of a thunderstorm.
A thunderstorm, as we mentioned at the beginning of this interview, it's from rising parcels of air that have moisture. And as they rise past the freezing level, they start to condense and then form ice particles. And these ice particles of different sizes will start to collide. And that collision creates this huge charge separation, electrical charge separation within the cloud. What eventually happens is the electric fields get large enough that once you generate a spark, the electric fields can promote that spark to get larger and larger. And that spark eventually forms what we would call like a lightning bolt. And sometimes those lightning bolts hit the ground, and sometimes, and if they do hit the ground, that would lower that charge to the ground, or they might just neutralize the charge separation within the cloud. And that's something that we would call cloud lightning.
Epic. Good stuff, sir. Thank you. And the fun fact I wanted to kind of air out to you all who's still watching over on News 6 Plus and on our YouTube channel is to kind of give Florida a bit more kudos in earning that lightning capital of the United States, especially given as small as the peninsula itself is, for example. We don't typically get lightning strikes too frequently in hurricanes. And if you all remember, in 24, we had Debbie, Helene, and Milton. And as Ryan explained, it all has to do with developing those charged cloud capabilities, ice crystals and glaciation within your updraft, developing the charge. And as we all know, tropical cyclones are warm. They're warm core throughout. So 9 times out of 10, you're never going to see hail. You're never going to get that crystallization in the clouds, which is why, despite all the thunderstorms and the heavy rainfall we get in the bands and in the core of a hurricane, you never really hear any thunder out there. So as we pull that map back up with the CONUS shot of all the density data provided to us, this guy right here, I'll take it full screen so you all can see real quick. If you notice, the peninsula is blanketed by those dark shades of red, and that excludes the hurricanes we had throughout the 24 hurricane season. And as we all know, in the very beginning of the year through spring and then now into the winter time, we really didn't have too much of a rainy/thunderstorm season. So it goes to show when the thunderstorms do pop and the lightning begins to sound off out there, it's pretty impressive. And then now, Ryan, before we get into one more heavy hitter question, I just wanted you to talk to this graphic, the global view of the data, because it looks like the United States jumps out at us. Is there any reasoning behind that? Any kind of clues or hints that you also could take away from this map that viewers may find interesting?
Yeah, this is a global density map, so similar to what we just looked at in the US, but all around the globe using our global lightning detection network. The US has some of the most intense thunderstorms around the globe. In the Midwest, we have something called MCSs, or mesoscale convective systems, that generate a ton of lightning. And of course, we see a lot of lightning in Florida for the reasons that we just talked about. There are other hotspots around the globe, Central Africa, parts of South America, and Oceania, have just ripe conditions for active thunderstorm development. So we see those trends reflected all around the globe in this image. And you'll also notice that most of the lightning is over land. And this is because you need, in addition to moisture, some way to lift the air up so that it can go to that freezing layer and form those ice crystals that we talked about. And you really only get, or you get much more common scenarios over land where you can get that vertical forcing just from heating the land masses from the sun.
That is really cool. And I also noticed that a lot of it tends to occur near the tropics and the subtropics. You don't get too much in the mid latitudes, let alone from there. And believe it or not, folks, just like we would say with our snow forecasts, it can be too hot and too cold for lightning to be produced. Everything with weather is all about keeping that balance, that equilibrium. And we won't get too much into that because I'd like to ask Ryan a couple more of the heavy hitter questions before we wrap up. So, for example, one that came across my desk earlier was their report found there was only one recorded lightning strike on Valentine's Day last year. How common is it to have such a low number, and what would you say contributes to this?
So again, the conditions for thunderstorms, the moisture and heating and some way to lift the air, those are pretty infrequent in the winter months,
Hmm.
especially, if it's very cold, air masses are very still. So it's not uncommon to see zero or just a few lightning strikes in the cold season here in North America. So it was just a fun tidbit that, hey, we just saw one lightning stroke on Valentine's Day, but it's not terribly unusual to see very little activity in the winter months.
That's kind of what I inferred reading that. It didn't mention whether or not this was globally or just for North America. And that makes a lot of sense because even right now, with the winter storms we have out there, Storm Prediction Center, National Weather Service isn't thinking we're going to have thunderstorms anywhere in the United States today because of just how cold it is. So that makes a lot of sense.
And it's definitely just the US. There's always lightning somewhere around the planet. In fact, our global lightning network detects 60 to 120 events every second of every day in the year.
Oh,
That
wow.
translates to around 2.2 billion events across the full calendar year. So there's always thunderstorms going on somewhere on the planet.
Well, there you go, folks. Kind of like that old adage, it's 5 o'clock somewhere. You know, you can find a thunderstorm somewhere across the globe, which is really interesting to note, especially in the middle of the winter time at night here when things are calm, cold, and collected. Somewhere there's ruckus going on that Mother Nature is causing. And now, before we move into my last question, which I think is the most interesting, I'll save the best for last. When is the busiest time for lightning? I kind of think I know the answer, but I'll go ahead and let you unravel that a bit for our viewers.
It definitely, well, first, it depends on where you are in the world, right?
Hmm.
So during the time of day, late afternoon is the high point for lightning. And then in North America, the summer months absolutely are the peak lightning season. It varies a little bit by region. Texas sees the most lightning in May. Midwest and East Coast see the most lightning in June, July, and August. So again, it's just what times a year gives us the proper ingredients for forming thunderstorms. And again, in North America, that tends to be late afternoon and summertime.
Copy that. Picking up what you're putting down. I'm hoping the rest of you guys out there watching and tuning in understand a lot of it does boil down to the finickiness or lack thereof of the overall environment. So, lightning is just as sensitive to produce as, say, a supercell thunderstorm or even a tropical cyclone. Everything needs to be in that balance. And then finally, before we run out of time, we have about 6 minutes left before the noon show starts and they boot us off here, Ryan. I wanted to ask, especially with your experience and how long Vaisala has been around, what sort of up and coming evolutions have you seen occur with the equipment, and where do you see us going over the next 5, 10 years? What kind of improvements would you like to see, and what are some that are already kind of in the makings?
For lightning detection technology, it's a really exciting time. As I've mentioned, Vaisala has operated the US network for over 40 years, and we expanded that to global coverage over 10 years ago. So, first, we are in an era where we can truly monitor lightning all over the globe in real time. And this has become increasingly important for uh, a variety of industry and business operations and personal safety. We at Vaisala keep working on this technology to make it more accurate, more comprehensive. And at the same time, there's other exciting developments that represent a complementary contribution to our understanding of lightning and lightning detection. One thing I'd like to mention is around 8 years ago, NOAA, the National Oceanic and Atmospheric Administration, launched on their latest GOES satellite, Lightning Imager, which is basically a video camera looking down from geostationary orbit. And that detects light emitted from cloud tops from lightning flashes.
Mm-hmm.
Now, it's not quite as precise, and it can't tell precisely where it hits the ground, but it provides amazing capabilities for mapping out the extent of a lightning flash. So we're really excited about that capability and how it complements the capabilities that companies like Vaisala can offer with our ground-based systems. And so I think out of this complementary nature of these different observations, you'll see more innovation, and we certainly strive to provide the best lightning data that we can. And these increasing capabilities just help us provide folks and businesses with real-time situational awareness and the tools that they need to really contend and continue smooth operations with increasingly uncertain environment that we all live in.
Absolutely. Wow. So you heard it here, folks. We're going to be going places, especially over the next 5 to 10 years. And I would imagine, Ryan, you could agree or maybe disagree, but part of it I do believe has to do with how much we're revolutionizing the electrical industry, the electric vehicles, trying to go full electric with a number of things that were once internal combustion or fossil fuel. So I'd imagine that Lightning and Vaisala will eventually try to, as you said, complement that industry, not only for protective purposes, but maybe even efficiency purposes. Would you think? Is that safe to say, or?
Yeah, there's lots of different angles that one can take here. One of the things that we included on our report is an analysis of lightning strikes to wind turbines. And
Oh,
wind
okay.
energy is becoming increasingly important in the US. It accounts for 10% of our capacity as of last year, I believe. And so as we continue with more electrification and energy sources, keeping these energy sources running and contending with curveballs that Mother Nature throws at us, like lightning strikes, is becoming increasingly important. So we spent a lot of time understanding how lightning interacts with wind turbines and what the industry can expect there as turbines increase in size. So these things are all interconnected and really are all quite dependent on our weather and environment. And we're doing our best to address those complexities to help the industry as a whole.
Excellent. Excellent information, folks. And that'll just about do it. We've got 2 minutes till the noon show, so we are going to go ahead and start closing out. Thank you so much to our News 6 Plus viewers as well as our News 6 YouTube viewers. Please feel free to check us out on clickorlando.com. We'll have a bit more of an in-depth discussion there, breaking down some of the data from their report, as well as an overall summary of today's interview. But Ryan, I want to say thank you so much for joining us today. We will definitely be in touch going forward, and if there are any questions that come out of the woodwork from our fans and viewers out there, you best believe we're going to send them your way, sir.
Wonderful. Thanks so much.
Alrighty, everybody. We will talk to you again very soon. But until then, this is the Digital Weather Center signing out. You guys have a great rest of your day.